Hello and welcome to the podcast on lead-acid batteries by Ramesh Natarajan. With industry experience of over 42 years, Ramesh helps battery and battery-related industries with technical inputs and provides solutions to typical problems faced by manufacturers, service personnel, as well as users of batteries and related equipments. Do visit www.rameshnatarajan.in to stay connected. Enjoy the session.
Hello and welcome to this episode of my podcast. Today I will discuss deep discharge of lead-acid batteries. The depth of discharge significantly impacts battery life. Deep discharge damages good quality batteries, which users ultimately term battery failure. Battery manufacturers generally specify the end of discharge voltage based on the battery's design and application. Any discharge below the end of discharge voltage is termed a deep discharge. Deep discharges, especially when more frequent, lead to battery capacity loss and degradation of the active material. Batteries subjected to deep discharges fail prematurely. In the case of lead-acid batteries, deep discharges damage both the positive and negative electrodes. The lead dioxide of the positives and the sponge lead of the negatives are converted to lead sulfate. This conversion is to such an extent that it is irreversible. In the case of positive plates, the active materials lose contact with the grids and tend to shed, which is detrimental to battery life and its continuing performance. When a battery goes into deep discharge mode, the specific gravity of the sulfuric acid electrolyte decreases and the acid becomes dilute. The solubility of lead increases and it tends to form thin fibers. These are called dendrites. The dendrites formed cause short circuits through the separators, thereby damaging the battery. Deep discharges can reverse the polarity of the negative electrode in negative plates. Once this happens, the plates can oxidize and the expanders used in the paste mixing operation can be lost. Automotive batteries are not cycled and are mainly used for engine cranking and the operation of specific accessories. They are recharged continuously when the vehicle's engines are on. Similarly, stationary batteries used in grid-supported UPS or inverter batteries as standby batteries are discharged in a controlled manner. The inverter stops the battery discharge once the set low cutoff voltage has reached the safety level. These batteries are recharged immediately after use and are not left idle as soon as the power supply from the grid resumes. They are also on a continuous float charge after a full recharge. Batteries that usually go into deep discharge mode are the ones that are used in cycling applications. Deep discharge of lead-acid batteries is often observed in the following applications: e-rickshaw batteries or EVs, traction batteries used in material handling applications, semi-traction batteries used in battery-operated vehicles, and stationary batteries that are used as standby power in solar photovoltaic applications. The deep discharge in the case of e-rickshaw batteries or traction batteries can be a regular occurrence. Such frequent discharges can have serious consequences on battery life and performance. This is because the effect of repetitive deep discharges can be additive. Hence, battery manufacturers specify that any discharge of such batteries beyond the 80% depth of their normal rated capacity is to be considered a deep discharge. Stationary batteries used for solar photovoltaic applications can be discharged fully on rare occasions. The batteries and the system are designed for a 20% to 50% depth of discharge, though the system has a 5 to 7 day autonomy. On rare occasions, when the battery goes into deep discharge mode, the manufacturers consider it deep discharge when the voltage dips below the specified end of discharge voltage. While discussing deep discharge, we must understand that the end voltage is not the only criterion for consideration. Sporadic and infrequent low voltages for a short period caused by a high current drawn from the load cannot be considered deep discharge. Such discharges to voltages below the end of discharge voltages do not damage the battery. These deep discharges, being infrequent and for a short period, do not considerably change the structure of the active material. When the load current is high, the voltages drop fast because of acid depletion within the pores of the active material. However, frequent short duration discharges will likely harm the battery as much as fewer low current deep discharges. Battery users must therefore ensure that battery usage is appropriate and in line with norms, and that deep discharge of batteries is avoided. Battery manufacturers must also train the battery users to obtain the battery's guaranteed long life. Thank you very much for tuning in. I hope you enjoyed this episode. Thank you once again.
Please do visit www.rameshnatrajan.in. Keep yourself updated about our new releases by hitting the subscribe button.